Hello everyone, it's Dr. J again. We're back looking at the function that we created yesterday called factorial function. And we did that using iteration or a for loop. And today we're going to rewrite the function using a recursive function because because it can be done that way. And it's a good illustration of recursion. Here to help me out today is Rifital. You want to say hi to everyone?
Hi.
Okay, so Rifital is volunteered to help me out today. And let's just document a little bit. So we're going to take this function out, this factorial function, which was written iteratively. We're going to take it out. First, let's run it. Make sure that this actually works, the iterative version. So we'll run it for 3 factorial. What should we get for 3?
6.
6, yep. So let's also run it for 5 factorial. What should we get?
120.
Correct. And let's run it for 0 factorial, which is by definition, right, and it works for that. Okay, so this clearly works for all small positive values of n. And now let's see if we can break it. I'm just kidding. But we're going to try recursion instead of iteration. So this is going to come out. And let's just take the whole body out. Okay. All right, let's get rid of that. All right, so what we're going to do for iteration, it's called divide and conquer. We have to have a base case, which we know that 0 factorial is 1, so that could be our base case. And we always begin with the base case. So let's begin with the base case. And let's test for the base case with an if. So if n equal to what? What would be the base case, Rifital?
0.
No, yes, 0 is correct. I was writing 1. You're right, I'm wrong. All right, so if n equals 0, we return what? We know the answer is?
Answer 1.
Yes. All right, otherwise, or instead of the word otherwise, we say else. And actually, we don't really need the else, but I like to put it. All right, so else, we return what? This is a tricky part. We realized yesterday when we were writing this that 5 factorial was really 5 times 4 factorial. And in general, n factorial is n times what?
N minus 1.
Perfect. So it's n times fact of n minus 1. So if we know how to solve n minus 1, we just multiply that by n and we know n factorial. So we do know how to solve 0 factorial, which is 1. So eventually it'll get down there and unravel. So let's see if that indeed will occur. Problem here, I used n1, now I used n. So let's use n1. N1 here, and one more, right?
Yes.
N1 here. Okay, so let's give it another shot. Maybe we get lucky this time. Clean compile. What do you want to try? 3 factorial?
5.
5. What should it be?
120.
Oh, lo and behold, it is. Now let's try running it again for 3 factorial, right?
Yes. 6.
Okay, and let's run it again for
0.
Yeah, 0. 0 factorial is 1. So it gives exactly the same results.
Yes.
And the coding, I think, is simpler. The only reason to use recursion instead of iteration is that it often simplifies the coding. Unfortunately, we cannot always use recursion However, for all recursive solutions, there's always an iterative solution, but not the other way around. Thanks very, very much for your help, Fatal. I think we'll
Thank you.
have a very brief recording today, and we'll be back tomorrow. Thanks so much. Bye, all.